Today in my genetics lab, we will be discussing Hardy-Weinberg equilibrium. Hardy-Weinberg equilibrium is when allele and genotypic frequencies will arrive at and remain at equilibrium frequencies after one generation of random mating if all assumptions are met. The assumptions a population must meet are as follows. There must be an infinitely large population, random mating, no selection, no migration, and no mutation. Let's take a walk down to the local frog pond and count the frogs. We see that there are phenotypically red frogs, phenotypically green frogs, and phenotypically reddish-green frogs. We count them all up and find that there are 23 red frogs, 57 reddish-green frogs, and 46 green frogs. Their genotypes are homozygous R, heterozygous RG, and homozygous G. To find out if our population is in Hardy-Weinberg equilibrium, we first have to calculate the genotype frequency by dividing each individual genotype by the total genotype, which is 126. We could also calculate allele frequency if we wanted to by doing this math here, but it is not necessary to determine Hardy-Weinberg equilibrium. We now have to do a chi-square test. Our null hypothesis says the population of red and green frogs have Hardy-Weinberg proportions for the color locus. We find that the chi-square value is 0.5168 and our critical value is 3.841. Our chi-square value is less than our critical value, so we are going to fail to reject our null hypothesis to determine that the population of red and green frogs has Hardy-Weinberg proportions for the color locus. Now that we know our population fulfills Hardy-Weinberg equilibrium, let's say that a new predator moves into the pond. The yellow snake easily feeds on frogs that show the red color because the green frogs can camouflage better in their surroundings. Uh-oh! This causes a Hardy-Weinberg selection violation! To determine the shift in the population, let's look at this chart. Our frequencies before selection and our relative fitness can be multiplied to give us our unadjusted survivors. This can then be added together to get our average fitness of 0.8365. If we take each genotype survivor and divide that number by the average fitness, we can determine the frequency after selection. Those should add up to equal 1. Now let's look at the before and after frequencies. Genotype RR went from 0.1825 to 0.1309, so they decreased in frequency. Genotype RG went from 0.4524 to 0.4326, so they also decreased. Genotype GG went from 0.3651 to 0.4365, so they increased in frequency. Since our results favor one extreme, in this case the GG genotype, we can conclude that directional selection has occurred. If this continued in an infinite number of generations, eventually all frogs would be homozygous GG and phenotypically green.